Hi everybody. First I want to apologize that I am not there. I was summoned to jury duty, so that's where I am today. So I need you guys to really work together and help each other out. If at any point in time during this lecture someone has a question or is struggling with their calculator, pause the video, help each other out, and then make sure everybody's on the same page. Okay, so we are going to talk about linear regression today. So it's a heavily calculator-driven topic for us. All right, so I've tried to show you step by step. I will try my best to explain it to you and show you what your calculator should look like. And if for some reason at the end you have any questions, Ms. Helene or Mrs. Bassini, they can certainly help you out. Okay, so let's go ahead and begin. And the first thing we need to do is get our calculator ready. Okay, so in order to do that, you need to go to Stat, okay, and your Stat key is right underneath your delete button. So if you look at my calculator picture, I'm highlighting the Stat key. Okay, you need to scroll down to Setup Editor, which is number 5, and then hit Enter. Okay, when you hit Enter, Setup Editor will be on your home screen, and once it says done, you're done. You might have to hit Enter one more time in order to get this done right here. Okay, after you've done that, go ahead and hit your clear key. All right, clear your home screen so it's a blank screen. Then we need to turn our diagnostics on. So in order to do this, you need to hit the second key and then your catalog, which is 0. You want to scroll all the way down to Diagnostics. If you take a look, you can just hit your the D button, and D is located at this x to the -1. That will get you to where all the D's are located, and then you just have to scroll down a little bit more until you get to Diagnostics on. Once you have that highlighted, hit Enter, and it'll shoot you back to the home screen. It will just say Diagnostics on. Once that's on your home screen, hit Enter, and Done should appear. Okay, so make sure everybody has done this. This is the only time you will have to set up your calculator. Okay, so from here on out, we can skip this step. Okay? All right, so if we are all ready to go, let's continue. Some of the vocabulary we are going to be talking about today. One is regression line. Okay, some of you guys might have heard of the phrase best line fit or line of best fit. Well, that's what a regression line is. It is a way to represent our data, okay, and it kind of shows us a relationship there. So whatever we are comparing, time and population, anything that we're comparing, okay? We're also going to talk a lot about a correlation coefficient. Okay, this correlation coefficient, it tells us how strong our regression line is. How well does it represent the data? Okay, if that value is close to 1, we've got a strong positive relationship, meaning as x is getting bigger, y is getting bigger, and they do so very neatly. If it's close to -1, that means we have a strong negative relationship, meaning as x is getting bigger and bigger, y is getting smaller and smaller. Okay, but there is still a nice relationship between the two. If our correlation coefficient is close to 0, the relationship isn't very strong. It's a very weak representation. Okay, so there's really no relationship between the data that we've collected. All right, it'll make more sense once we get into some examples, but you have to be aware of the vocabulary. Okay? Okay, now go ahead and turn to number 7 in your packet. We're going to get started. All right, it's a growing world problem. All right, so here you really need to make sure you're helping each other out, getting our calculator completely ready to go. Okay, so the data show the increase in the world population over a 300-year period. Okay? So, in the year 1650, the population is 510 million people. So take a look at what your units are. All right, and in 1700, it's 625 million, 1750, 710 million, etc., etc. So here is our information right there. Okay, now initially what we are going to be doing is we are going to be graphing a scatter plot. So essentially just points. All right. And then we're going to create a line of best fit, our regression line, to see how well the years and population go together, all right, what the relationship is, okay? So before we get started, we have to understand these lists, all right? List 1, typically, we will represent with our X values, okay? The independent variable. In list 2, that will be our Y values, the dependent variable. Okay, so in this case, the independent variable is going to be the year. All right, so our first list is going to be the year here. So I'm going to zoom in a little bit on this list so we can fill it in. Okay, so in 1650, now instead of calling this 1650 right here, I'm going to call it year 0. All right, so we are going to let year 1650 really be year 0. All right, so that means in 1700, that is year 50. And in year 1750, it's year 100. And in 1800, it's year 150. And in 1850, it's year 200. And in 1900, it's 250. And in 1950, it's year 300. Okay? All right, so let's go ahead and fill in list 2, the Y values. All of the population. Okay, so that's simply just rewriting that column. So in year 0, it is going to be 510. In year 50, the population is 625 million. And in year 100, it's 710. Year 150, it's 910. Year 200, it's 1130. In 250, it's 1600. And in 300, it's 2510. Okay, so now we've calculated, or we've created our lists. Okay, now it's time to enter these lists into our calculator. So I'm going to scroll down a little bit because part A, we want to get to our regression line, our equation. All right, well, in order to do that, I need to show you how. Okay, so here are my notes down below, and we'll go back to A. Okay, so follow along with me on your calculator. All right, the first thing you need to do is hit your stat key. And again, that stat key is right below the delete. Okay, then you want to go down to edit. So it's going to be your first option, and hit enter. When you do that, this should show up on your screen. Okay? And now some of you might have some numbers in list 1 and list 2. If you do, scroll all the way up until L1 or L2 is highlighted, then hit your delete key and enter. It should clear the lists. Okay, so you want these totally cleared. All right? And now what I want you to do is enter list 1, your X values, right here. Okay, so go ahead. This is going to take a little bit of time. Enter your lists. Okay, and in list 2, you're entering the Y values. What we set up above was our list 2. So take a second, go ahead, enter the lists. All right, and if you need to, pause the video until everybody is ready to go. Okay, so if you still need more time, go ahead and hit pause. Okay? Otherwise, let's move on. So the next step, I want you to go to your home screen. So hit second quit. Okay, so your screen, you should be back here. Clear everything just for kicks. All right? Okay, next thing I want you to do is go to your y equals. So your y equals is that top left button right there. Okay, so refer to my calculator for reference. All right, so what you should notice is all of this should be clear. Check all of your y equals, make sure nothing is located in there, and take a look up top. Make sure your plots are not highlighted. We'll be highlighting one later on. So if they are highlighted, scroll up to it. Once it's highlighted, hit enter, and that should unhighlight it. Okay? All right. So now from there, you can go ahead and hit stat plot. This is your second y equals. So hit second, then y equals. And what you should go to is this screen right here. All right? So we are going to turn our stat plots on. So what I want you to do is hit enter when number 1 is highlighted. Okay? So what we are going to do now is you should be at this screen. I want your screen to look exactly like mine. So I want on to be highlighted. I want your X list to be list 1. Your Y list needs to be list 2. If for some reason your X list is not L1 and your Y list is not L2, you can simply change that. All right? All you have to do is highlight whatever list is there. And then you're going to hit, for your X list, you're going to hit second and then number 1. If you take a look at number 1 and second, there's an L1 in blue in that corner. For Y list, to get L2, if it is not L2, you're going to hit second and the number 2. Okay? Once your plot looks like this, you can go back to your home screen. Okay? So go back to your home screen, and now we're ready to go to the next step. Okay? All right. So after you've done all of your plots set up, now what I want you to do is hit zoom, all right, number 9. So your zoom key is that middle top button. And I want you to scroll to number 9. Number 9 is zoom stat. What this is telling your calculator to do is it's telling your calculator to create a window around your data points. So those are our data points right there. Okay? So that's our scatter plot right now. Just those data points from L1 and L2. Okay? So that's what it looks like. All right. Okay, the next step is to get our regression line. All right, so follow these directions very carefully. All right, so you should be back at your home screen now. So hit second quit, get out of that scatter plot. Okay? All right, so the next thing we need to do is go back to your stat key. Okay? So you hit stat. This time you're going to scroll to the right to calculate. All right? So if you scroll to the right, you're going to have a list of choices. You want to choose number 4, linear regression. So it looks like this. All right? So it should shoot this linear regression back to your home screen. Do not hit enter at this point once this is on your home screen. Okay? What we're doing right now is we are telling our calculator where to put our linear regression line. Now at this point, some of your screens might look different. Okay? Some of your screens might have this linear regression, and it might have some options here. It might talk about list 1, list 2, all right? And it might ask you where to put your line. All right? And you want to tell it to put your line in Y1. So how do we get that? Okay? Again, some of yours might look just like mine. Okay, so this is kind of the tricky part. We need to tell the calculator to put our line into our Y1, our Y equals. Okay, so how do we do that? Well, from this screen right here, the next thing you have to do is go to your variables button. If you take a look on your calculator, this variables button is to the left of your clear button. So find that. Okay? So hit variables. Then you're going to scroll to the right. You want your y variables. Okay? We want to shoot it up into our y equals. And we're dealing with a line, which is a function. So choose function. And then your first choice is going to be y1. So you hit enter. Okay? And what your screen should look like now is this. Again, some of you guys might have another screen, okay, the newer calculators. So if you do, you want to get y1 in there to tell your calculator to get to the y equals. And you do that the same way I just told you. It's just going to be in a different part of your calculator. Okay, it's just going to look different. So you still would go to variables, you'd go to y variables, function, and y1. So you need y1 in this screen. Now you can hit enter. Okay, so once you hit enter, you should get all of this information on your home screen. Okay, this is all the information for our regression line. All right. So there's an A value, there's a B value, there's this R squared and R. Well, I don't want you to pay any attention to this R squared. We don't need that right now. That's going to be later on when you get into some stats courses. Okay? Right now we're going to keep it kind of basic. So, if you take a look, we're going to be writing the equation of a line. Y equals AX plus B. We have an A value, which is our slope. We have the B value, which is our y-intercept, and we have this R value. This R value, that's our correlation coefficient. That's important. All right? So, there's our correlation coefficient. Now, I want you to write all of this down for number 7a. All right, so make a side note, hey, our A value is equal to 5.98. We're rounding to the nearest hundredth. Our B value is 245.36. And our R value, our correlation coefficient, we round to 4 decimals. So our R value is 0.91. Rounding to 4 decimals is going to be 50. Okay? All right, so hopefully we are all on the same page here and we got this equation. All right? Now, what I want you to do is just kind of take a look. All right? Oh, sorry, before we do that, let's write down our final equation. All right? Because part A wants us to write down the equation. The equation is going to be y equals 5.98 x plus 245.36. Okay, so here's the equation for our regression line. And if you take a look, our correlation coefficient, 0.9150, that's pretty close to 1, right? So I would say there is a strong positive correlation between time and population. All right? So as time keeps going, population keeps increasing. Okay, so you write this information down. We've got that. Let's just take a look. If you go back to your y equals key, what you should notice now is that your linear regression line is in y1. Well, that's where we told the calculator to put it. Okay? And if you hit your graph key, the very top right corner, it's going to show you what your regression line looks like with relation to your data points. Okay, so that's kind of cool. Now you can kind of see, oh, my data is pretty close to that line. All right, so it is a pretty good representation. Okay. Okay, so let's move on to part B. We are going to use the equation we got in part A to predict the population of the world in 2050. So now this is completely calculator from here on out, okay? So we are using our calculator, we are using that exact regression line, all right, which is going to represent our data, okay? So we want to figure out in year 2050, what's the population, okay? Well, remember we said in year 0, it was 1650, right? So in year 2050, what does X really represent? Well, X represents 400, right? Because that's 400 years after the year 1650. Okay, so what I need you guys to do now is I need you to go to your graph, okay? So you should be at this graph right here, okay? Now you might not have anything like this down below, but you should be at your graph, okay? What you need to do is hit your trace key. Trace is located at the top, second from the right button, okay? So hit that key. And what you want is you want your cursor on your regression line, all right? And if you look at the top of your window, that will tell you what you're on, okay? So if you're on your data points, it will have a L1, L2 up here. So what you'll need to do is scroll up. So hit your up arrow on your calculator. And what should happen is you should now be on your line. I see Y1 and my cursor is on my line now. It's not on data points. Okay? So from here, I want you to hit the number 400. So just type in 400, enter. Okay? And what you should all realize is, oh no, I got an error. Okay? If you hit go to, all right, so scroll down to go to, your calculator is going to come back down to this corner and say this 400 doesn't make sense. Well, what that means is we're going to have to change the window. Okay, our X values aren't good enough. All right, they're not big enough. So if you go to your window, and your window is this button, the top button, second from the left. Okay? And what you should notice is that your X maximum did not go to 400. So what I want you to do is change this X maximum here to 450. Okay? Once you've done that, hit your graph key again. Go back to your graph. And then I want you to hit trace 400, enter again. But again, before you hit enter, you need to make sure that you're stuck on your line. So when you hit trace, check to make sure you're on your line. If you're not, you have to scroll up or scroll down. Okay? So once you're on your line, hit 400, hit enter, and you should get an answer like this down here. Okay? So here's the work that I would want to see. All right, tell me your keystrokes. Well, we hit trace. After we hit trace, we hit 400 because that's what we want. We want the X value to be 400. And then we hit enter. And we got this ordered pair. Okay, the ordered pair was 400, comma, 2,636.79. Okay, and the last thing we have to do is interpret this because it wants to know what the population is. So our final answer is going to be the population is about 2,636.79 million people. Okay, so next we're going to look at part C. Use the equation in part A to predict in what year there will be approximately 5 billion people in the world. No guess and check. So I want exact. I want you using your calculator. I want you using the regression line that we came up with. Okay? All right. So one way we could do this algebraically, right? But I want us to use our calculator. So here's our work again. Okay? This is the work I would want to see. We know that in Y1 we have our regression line. right? 5.98x plus 245.36. Well, I want to figure out the x value this time. I know the y value. We know y is equal to 5,000. Remember, it's in terms of millions. So in y2, we're going to let y2 be 5,000. Okay, so if you take a look, you go to your y equals, okay, your plot should be on. You should have your regression line in y1. I want you to plug y2 is 5,000. Okay, now if you were to graph this right now, you need to be able to see the intersection. Okay, but if you were to graph it right now, you probably cannot see that horizontal line of y equals 5,000. So you need to change your window. Okay, so I forgot to put this slide on here, so I'm going to just kind of walk you through it. Go up to your window screen and change your x maximum. I'm going to help you out right now. Your x maximum needs to be, let's make it 1,000. And you'll change your y maximum to, let's just say 6,000. All right, just to be safe so I can see everything. All right, now go ahead and hit your graph key. So you should be looking at your graph, and hopefully you can see the intersection point. Okay? All right. So the next thing I want you to do, the next work that you need to show me are your keystrokes. So do you remember how to get the intersection of two lines? I know we talked about it last year in geometry. We might have even talked about it this year. So what we need to do is go to our calculate key. So we're going to hit calculate. Now our calculate key, if you take a look at my calculator up here, it's really second trace. Okay, so we go to calculate, and what are we going to choose? Look at your options. Okay, we're going to calculate the intersection. So we're writing our keystrokes down. So we calculate intersect. Okay, and when you do that, your calculator is going to ask you if you're on your first curve. So you'll see that in the bottom left-hand corner. First curve, all you're going to do is hit enter. Okay. And then it's going to jump to, your cursor will jump to the second curve. So it's going to ask you, are you on your second curve? And you hit enter again. And then it will ask you for a guess. Well, if you want, you can move your cursor closer to the intersection and then hit enter. And if you do, what you should see is your calculator gives you these ordered pairs. Okay, so I'm going to write that down. And that's what you should have all gotten. So we should have gotten 795.28, 5,000. Okay, but now we need to actually answer the question accordingly. Okay, it wants to know in what year. Well, remember, our year started in 1650. That's year 0. So I am going to add 795.28 to this to figure out what year this is. Okay? And what we get is 2,445.28. Well, I don't really care about these guys here. All right? I'm just focusing on the year. So it's in the year 2,445. And it's only 2,445 because it's only a fraction of the way through, that 0.28. So I don't worry about that. I'm simply focused on what year. So there is our year. Okay, part D. What is the horizontal intercept and what does it represent in the real world? All right, well, horizontal. Which axis represents the horizontal axis? Well, that's our x-axis, so it's really asking for the x-intercept. Okay, and in this case, it's the time intercept, the year's intercept. So how do we calculate that? Well, one way to do it is we can let y2 equal 0, and we can calculate the intersection. Okay, that might be the easiest route to take. The other way is you can calculate the 0. So there's two ways you can go about it. One is letting y1, that is equal to our equation, 5.98x plus 245.36, and then we would let y2 equal 0, because we want to know what's x when y equals 0. Okay? So if you do this, now you are going to calculate the intersection So you're going to go through, okay, are you on the first curve? Yes, enter. Second curve? Yes, enter. Guess, enter. And what you should get is the ordered pair, negative 41.04, comma 0. If you got an error, that means you couldn't see your intersection. So you have to change your window. Okay, so go back, change the window around, and try it again. All right, so what does this say? What does this mean? Well, technically, it's saying in the year 1608, the population was 0. Does this make sense? In 1608, were there people around? Yeah, I think so, right? So, technically, there's really no significance here. Okay, remember, our line of best fit really represents data from the year 1650 on. Okay, so it doesn't necessarily represent the data before then. All right? The other way that we could have found the x-intercept would be to calculate a 0. I'll show you this step later on. Okay, so we won't worry about that quite yet. All right? Part E. What is the vertical intercept and what does it represent in the real world? Well, what is the vertical intercept? The vertical axis. That is our y-intercept. Well, this one hopefully requires absolutely no work. We have our equation. Y equals 5.98x plus 245.36. What's your y-intercept? Well, hopefully you're all able to tell us there's our y-intercept. Okay, but what does it mean? So our vertical intercept is 245.31. What does it mean? It means in the year 1650, the population was 245.31 million. All right. Now again, that's not what our table showed us for the year 1650, but we're basing it off of this regression line. Okay? Okay, getting down to it. What is the slope and its units? Okay, describe the slope in terms of its real world meaning. Okay, so we've kind of talked about interpreting slope before. So let's look at our slope. Our slope is 5.98 over 1 essentially, right? Well, what are the units for our y's? Well, it's millions of people. It's the population. And our x is years, right? So how can we interpret this? Well, what this is saying is that each year since 1650, the population has increased by 5.98 million people each year. Okay, so again, interpreting that data, interpreting your slope, put units to it, tell me exactly what it represents. Finally, what does the correlation coefficient tell you about the model and the data? Well, remember our correlation coefficient is 0.9150. And since this is close to 1, okay, it tells us that it's a good line of best fit. It represents our data well. It also tells us that there is a strong positive correlation or relationship between time in years and population. Okay, so yes, this was a very heavy lecture. I apologize that I wasn't there. If you have any questions, let me know. Okay, hopefully I'll see you tomorrow. Bye-bye.